All right. So another concept that's important now that we've kind of established a new type of kinematic quantity, that of angular quantities as opposed to translational quantities, it's important to note that the two are not independent of one another. If you're traveling in a circle, then you can describe your motion in terms of both the radius of the circle you're making and the angular displacement. And you can also describe this in terms of the distance you travel around the circle. And we've already kind of established that when we built up the unit of the radian. Um, the arc length you cover is a measure of distance. So arc length is a displacement, or rather a distance traveled. And that distance, which would be measured in meters, is simply equal to the angular displacement. And notice that those two things seem like they're kind of describing the same thing. They're both kind of referring to a change in position multiplied by the radius of the circle that you make. This sets up basically a pattern that you can continue to follow and will always work, meaning if you want to change from a rotational quantity of a certain type into an equivalent translational quantity of that type, you simply take the rotational quantity. So for example, let's say we had an angular velocity. If we take an angular velocity and multiply it by the radius of the circle we're making, what do we get? We get our speed with which we travel around the circle. Similarly, if you have the rotational quantity of angular acceleration, you multiply that by the size of the radius of the circle that you are making with your circular trajectory, then what do you get? You get the magnitude of your tangential acceleration around the circle. So that's nice.